and kindly stay connected as this session promises to be an insightful and impactful one. My name is Nancy Osei. I'm a member of the SP Career Guidance and Outreach Committee, and I'm honored to be your moderator for this session. A special thanks to my executives for this great opportunity. So, our focus for today is on the future of energy, and we'll be looking into opportunities for young professionals in a changing industry. So this is our outline. The house rules will be communicated to the house, and we'll have the SP Safe Start. And this is a safe space. We'll have an opening address to introduce the speakers. Then the main discussion will flow. We'll have our Q&A, upcoming events, and finally, our vote of thanks. So kindly mute your microphones to prevent any distractions, and also use the raise hand icon if you have any questions and you'll be called to speak. You can also use the chat box, text all your contributions and suggestions in the chat box and they'll be read. Yes, and this is our SP Safe Start. SP Safe Start highlights the integration of advanced energy technologies, yes, and with strong safety systems. You know that as energy systems become smarter and cleaner, safety must remain a constant priority. And the future of energy is bright, but it is safety that will keep that future shining. So this is a safe space. We are all here to learn, to share knowledge, and to connect. So feel at home, yes. And so kindly react with any of the emojis here. We want to know how you feel about joining this meeting. Hello. Please, I'm not seeing your reactions. Please, can you hear me? Oh, okay. I'm seeing them. All right. That's good. Okay, so we'll have our Deputy Career Guidance and Outreach Chair to give an opening address, and he's in the person of Engineer Daniel Opon. So, Engineer Opon, please, over to you. Okay, it looks like Engineer Opon. Okay, so we'll move ahead. It looks like Engineer Opon is not yet in. All right, so next we have our speakers here, and we are honored to have them join us. So our first speaker is in the person of Ray Square. He's a base manager with Saudi Construction Limited. And with over 35 years of international experience in welding and fabrication, quality assurance, quality control, supervision, and expediting. He has deep expertise in welding technology, materials, procedures, testing, and global construction standards. He has worked on onshore and offshore projects in oil and gas, petrochemical, mining, and energy sectors across Africa, Europe, the UK, Australia, Asia, and the Middle East. Yes, these multinational environments have strengthened his ability to adapt, communicate clearly, and deliver results in complex and high-pressure settings. Through ongoing personal and professional development, he has cultivated a focused and initiative leadership style. His dedication to excellence, perseverance, communication skills, and self-discipline enables him to push boundaries, challenges assumptions, and continuously improves performance. So, Ray Esquire, you are welcome, and we are pleased to hear from you. Please, over to you. Okay. Okay, before the presentation, Engineer Daniel is in now. So we would have an opening address from Engineer Daniel. Engineer Daniel, over to you.
Hi, sorry. I just missed the timing a little bit. Thank you all for joining this convocation of smart, amazing individuals put together to show us the pathway in this industry. As we all know that steering your path in this industry doesn't just come very simply. Oftentimes, if not being well guided, you can find yourself in an area that is not aligned with your passion and with your strength. So what this webinar seeks to address is to help us find a strong footing, identify our strength, and help us to be able to develop passion for this industry. And I hope you all will learn from the experiences and the pathways that will be shared by various individuals who are going to share their stories and their expertise with us. So take the time, ask questions, and learn so that it will be beneficial for you in the future and even in the very moment. Thank you all, and I hope you have a great day. Thank you.
Thank you very much, Engineer Daniel, for this great opening address. So moving on, we'll introduce our first speaker. And our first speaker is a senior operations and mechanical engineer with over 10 years experience bridging OT, IT, and plant operations to create safe, efficient, and data-driven systems. Certified in PMP and PMI ACP, he has led complex projects, implemented predictive maintenance, and driven operational excellence. As a co-founder of Alvasa Web, he delivers secure web and cybersecurity solutions. He's passionate about automation, machine learning, cybersecurity, and technology education. His session will focus on smart energy, showing young professionals how to leverage digital twin technologies by integrating OT and IT to solve energy challenges and develop the skills needed for a rapidly evolving industry. And he's in the person of Engineer Suleiman. Engineer, you are welcome. Over to you.
Okay, thank you very, very much. Good afternoon, everyone. I'm audible.
Yes, please.
Hello, audience. Are you here with us?
Yes, sir, we
Yes,
can hear you.
Yes.
Okay, all right. Thanks. Good afternoon once again. I really want to say a very big thank you to SP for giving me this opportunity to share my experience with young professionals. As a moderator said earlier, my interest today is of smart energy and introduce you to the digital twin technology as well. So my session, what I want you to learn from here is most of you here are engineers. I want you to know that engineering technology, engineering fundamental is essential. But the industry is changing, you are supposed to also adapt what is happening. So we'll talk more about it. But we have permission to share my slides. Okay, can you see my slides? Please, can you see it?
Yes, we can.
All right, thank you. Please, the discussion, they are not here to do lecture. So we also want to do presentation also. All right. So as I said earlier, yeah, I'm going to talk about Monday. Oh,
Okay, hello.
Hello, everyone. Please, we are having some challenges with the sound. We'll rectify it in the shortest possible time. Kindly hold on a little. While we are waiting, can the host just play the safety videos from VLC while we wait?
Okay, hello. Please, can you hear me now?
Yes, you're audible.
Okay, apologies for the break. And so we'll move on to our next speaker, probably after he's done. After he's done, Engineer Suleiman might be back. Okay, so all right, so we have our next speaker on the line, and he is an engineer with over a decade of experience in upstream and midstream oil and gas. He holds a BSc in petroleum engineering, Master of Engineering in Oil and Gas with Management, an MSc in Sustainable Systems Engineering, and he's currently a PhD student at the Ohio State University. His career includes roles at Tullow Oil as projects and reliability engineer, at the NPA as inspections and monitoring officer, and currently a senior operations engineer at the Ghana National Gas Company, where he focuses on optimizing plant processes, ensuring equipment reliability, and overseeing inspections and maintenance reporting. Our speaker is in the person of Engineer Abdallah Gali Mashoud. He's a senior operations engineer with Ghana National Gas Company Limited. Engineer Mashoud, please, you are welcome.
Thank you, and
Okay.
thank you for having me. I just want to say good morning from my side to everyone, and
Good morning.
thank you for having me. Yeah. So, unfortunately, I didn't prepare any slides due to some busy schedules, but I mean, we could have an interactive session on this very important topic. So, um, so if let's start from this scenario. Imagine waking up 20 years or 30 years from now and explaining to your kids what it was like to live through the largest transformation of the global energy system in history. As we are all aware, we are going through one of the largest or the biggest energy transformations globally. Europe and the United States have made significant strides from gravitating towards obtaining energy from fossil fuels to um, renewables, right? Decarbonization, that's what everybody's talking about. But then this is not just a gradual evolution, but a complete redesign. Um, as we all are aware, energy has always defined civilizations. That is the fundamentals of civilization. Without energy, we would not really enjoy what civilization is. And coal powered the Industrial Revolution. I mean, in the olden days, it was predominantly coal. Then we had oil, which shaped geopolitics, natural gas, which transformed our electricity markets. But then, if you look at today, something unprecedented is happening. We are gradually gravitating from centralized to distributed systems. And so that's from fossil based to low carbon. That's what I said earlier, decarbonization. Yeah, from analog grids to intelligent digital networks. If you go to what we call the International Energy Agency, global clean energy investment is what is now being measured in trillions annually, and it keeps rising. And so this is not just a simple environmental movement, it's also an economic revolution the world is undertaking, a technological revolution as well, and a workforce revolution. And that is where the main focus would be, the workforce revolution. And so the most important or imperative question is not whether the transformation would happen. The question is who will build it. And we're already seeing that already. I mean, in other parts of the world, in the United States and in Europe. Um, Even though there's a bit of politics in this whole entire movement of gravitation, right? As you are aware, the current president of the United States does not believe in decarbonization. He doesn't believe in sustainability. He believes it's a hoax. He believes we should continue tapping energy from fossil fuel sources. And but Europe is fast-paced moving towards decarbonization. United States was doing same, and they had the largest investment in the world. United States and Canada. But unfortunately, because of political shifts in the dynamics, the Republican side of the of the government, or the Republican Party, so to speak, are not in support entirely of sustainability. It doesn't align with the president's vision. And so lots of these decarbonization and sustainability projects being pursued by scientists, researchers, somehow some have been put to a halt, and some are still ongoing though, but not as compared to the how it was during the Estival administration, which was Democratic Party. And so if we look at the opportunities our young, um, what do you call it, professionals should be looking at, especially now that the world is embracing decarbonization and sustainability and digitalization, so to speak. I think Sule was going to speak about it as well. So I'm just going to touch a little bit on it. Um, we need to stand out differently as young professionals. You just don't go to school and acquire your bachelor's degree in petroleum engineering and that's it. Because as a petroleum engineer, your fundamental responsibility is to go and extract oil and gas or hydrocarbons from subsurface, and anything associated with the process. But then today we have petroleum engineers who are learning who are doing machine learning stuff, who are what do you call it, equipping themselves with all the soft technical skills, and also gravitating towards courses that would enable them to be able to stand out in terms of the decarbonization agenda or drive the world is currently driving. And so, one, you need to try as much as possible to equip yourself with some technical skills apart from just your bachelor's degree, chemical engineering, petroleum engineering, mechanical engineering. What are you going to do differently? And so we look at renewable energy engineering. I mean, even with the renewable energy engineering, you still need to have a broader perspective in terms of incorporating the things that are necessary or the things that are pertinent to the global movement. You just don't go and what do you call it? Acquire a bachelor's certificate and say that, hey, I need a job. There are tens of millions of your caliber or type who have the same degree around the world, and we're having a very competitive industry nowadays that um, you, that requires that you should also have something unique or exemplary for other people to look at you and say, hey, he stands out or she stands out. And so I would implore all my young professionals to take their IT skills very seriously. You should learn how to code. I mean, I'll be very honest with you. In our part of the world, I know this thing has not been very emphasized, but I would tell you that if you go to other parts of the world, as engineers, one of your biggest stumbling blocks would be your inability to code. I'm not gonna lie to you. This is not the 1980s or the 1970s. These days, people want to make things easier and much faster. And so, my process engineers here would keep talking about optimization, trying to maximize profit at the least possible costs, whether it is equipment optimization or anything optimization. So these IT skills or soft skills would enable you to do things faster. By doing things faster, one, you are able to save cost. Number two, you are able to maximize profitability. And so it is very important that we do that. And number two, too, SP provides a very big platform for us to interact with very experienced professionals who can at least encourage us and talk to us about some of these certification programs, right? You don't need to go back to school to do a degree or a whole 4 years or 2 years to be able to have sustainability, what do you call it, degrees or certifications. There are so many of them online, that's very accredited universities and very reputable universities across Europe and United States, Canada, and even in Africa are actually offering. And you could just get in there, apply, and try to see if you can pursue one or two in order to add value to your already existing certificates or certifications. And so it is very, very, very important that we look at that. Additionally, I would also encourage you to um, try as much as possible to keep yourself abreast with contemporary matters regarding decarbonization. Read magazines. There are lots and lots of European magazines. There are lots and lots of US magazines you should be reading to know where it is going, for you to be able to appreciate the trajectory and to acquaint yourselves properly and adjust accordingly. And so you just don't, because Africa, we seem to be a bit behind when it comes to this whole decarbonization, because we see that um, the United States or the West, they started producing hydrocarbons and polluting the environment for over 300 years before Africa even discovered oil. That is the theory. And so they have polluted enough. They should allow us to also enjoy the benefits of oil and gas. And later we will join them in making those significant strides. But then climate sciences are, they keep warning the abrupt rise in sea levels, global warming. The globe is getting warmer and warmer. When it comes to emission of this chlorofluorocarbons, these things were already so much have been done about them in the past, and so the issue here fundamentally has been with carbon emissions, and the predominant or the most carbon emitter sources of energy are from coal, followed by crude oil and natural gas, and so gradually we're moving away from there. But then Africa too has to contribute. Africa has to try as much as possible to contribute its quota towards these significant strides Europe and America are already doing. And it behoves on the younger generation, you, to be able to have the requisite expertise and the best of careers to be able to champion this drive. And so um, I would not take so much of your time. I would just, what do you call it, itemize a few things that we're currently seeing as far as decarbonization is concerned. The major shifts defining the industry now, we're talking about one, electrification. Some of you, as you're aware, there are a few electric vehicles already in Ghana. So we are moving from the internally combustion engines to EVs. That is from ICEs to EVs. So in order to just minimize carbon emissions. And so for you to understand the brains behind this, you need to do what we call sustainable systems engineering or sustainability or renewable energy systems engineering or energy systems engineering. We also have smart grids. We have energy storage systems. We have distributed generation as well. Then when you look at renewables at scale, solar and wind, this is something that is not very common in Ghana, but I do think we have a few plants. I'm told Viari is putting up a few in Upper East as well to be able to make use of the heat or the sun, what do you call the solar energy we have in the northern part of the country, Upper East in particular, which is a very good move. And so when you look at these areas, you should know the kind of soft skills to acquire or the kind of, what do you call it, certification programs to pursue to be able to leverage on some of these opportunities, right? I did earlier spoke about the digital aspect of the whole thing. Sule would elucidate further on that. The new energy careers as well. We have the green hydrogen, we have sustainable aviation fuel as well, and we have advanced biofuels, and then smaller modular reactors. All these are quite advanced technologies that have been adopted by Europe and America in terms of trying to have a sustainable future. And so we all know what green hydrogen is. Once you hear green, you know that it is sustainable. It is not something that has a significant impact on the environment. Climate scientists would talk about what we call very good. This just came to mind. Our young professionals also try to one of the very fundamental certifications I would encourage you to look at is life cycle assessment certifications, LCA, right? A life cycle assessment is basically trying to evaluate the environmental impacts of a product or anything. It could be anything. You try to see right from production to disposal, what is the environmental impact? Are you producing any carbons? Are you emitting any carbons? And all of that. These are very much respected and very much required certifications you would need. So that's also another one you would have to look at. And I would just conclude on this by saying that, you see, every generation inherits an energy system. Few generations get the opportunity to rebuild one. So if you are entering the industry at a time when grids are becoming more intelligent, molecules are becoming cleaner. When I say molecules, we are all engineers here. I guess you know what we're talking about. And the markets are also becoming carbon aware, and energy careers are becoming multidisciplinary. Indeed. And so the tradition that's been practiced now is that once your fundamental source of energy is from coal or fossil. In Africa, I'm not pretty sure we derive most of. I don't think we even actually have coal plants. I stand corrected, but in the United States and other parts of the world, we have a lot of coal plants actually, which are the biggest emitter of the CO2s, and so Africa has to contribute. We cannot say we are lacking behind, and so we have to produce more and more, and so there will be technological failures and policies that would affect these things, that would thwart these what do you call it, these visions or these objectives or goals. There will be resistance, there will be volatilities, etc. But here is what the history will teach us: transformation creates opportunities faster than stability ever could. The engineers who built our pipelines, for example, once built fiber optic cables, right? The utilities that resisted renewables are now leading storage deployments. The oil majors, if you talk about the ExxonMobils, etc., are investing heavily, significantly in hydrogen and offshore wind. The future of energy is actually not about abandoning the past. It's just about trying to, evolve. So it's about evolving it. We're trying to do something better out of it, right? And so we are not totally or entirely abandoning the past, which was the normal norm of going offshore and producing oil or gas and all of that. We're just trying to do something better so we can mitigate CO2 emissions. And so these are all areas our young professionals can take advantage of. You should be digitally naive. I mean, you should be digitally curious. Sorry, you should be climate conscious, and you're not constrained by legacy thinking. So energy is not just an industry; it is the backbone of economic growth, healthcare, education, national security, and human progress. And so you are not just choosing a career; you are choosing to shape the infrastructure of the future, right? And the energy transition will define this century. You may not know, or you may not see it, but maybe the generations that are yet to be born would probably appreciate your works. And so, in decades from now, when someone asks who built the system that powered a cleaner, smarter, and more resilient world, the answer can be we did it. This is where I have to stop and leave you guys to ponder. Thank you very much.
All right. Thank you very much, Engineer Mashood, for this great presentation. Yes, personally, I'm taking home a lot. I've learned a lot. And two things you said, that we should keep ourselves abreast with contemporary matters concerning decarbonization. And also, we should consider this fundamental and required certification, which is the LC, the Life Cycle Assessment Certification. Thank you once again, Engineer Mashood. So
You're welcome.
next, we'll move to our next speaker. And he is a senior operations and mechanical engineer with over 10 years experience bridging OT, IT, and plant operations to create safe, efficient, and data-driven systems. Certified in PMP and PMI ACP, he has led complex projects, implemented predictive maintenance, and driven operational excellence. As co-founder of Alubasa Web, he delivers secure web and cybersecurity solutions. He is passionate about automation, machine learning, cybersecurity, and technology education. His session will focus on smart energy, showing young professionals how to leverage digital twin technologies by integrating OT and IT to solve energy challenges and develop the skills needed for a rapidly evolving industry. And our speaker is in the person of Engineer Suleiman Zakaria. Yes, he's a senior operations engineer at the Ghana National Gas Company Limited. Engineer Suleiman, you are welcome, and over to you.
Okay, thank you once again. I hope I'm very audible now.
Yes, you are.
Okay. I also want to say a big shout out to my brother Mashood. I hope you are doing well. Long time. Nice presentation.
Yes, sir. I am doing well. I hope you are too.
Of my life.
All right, big boss. Okay.
I want to let's go to my slides. I think time is on. I hope you can my slide. Please can you my slide.
Yes, we can see your slides.
Yeah. So as I said earlier, I want to talk about bridge the gap between bridging the gap about smart energy and digital twin. What I want everyone to understand here is, as my brother talked about, the world is moving away from traditional way of doing things. Now it's all about data, smartness, and intelligence. We are all engineers and already know the engineering fundamentals. Some of us are also working in industries like the gas processing plants, power generation, and what have you. So you're already dealing with OT, which is the operational technology. Now, what you want to do is you want to infuse the information technology into your OT engineering. So energy sector is clearly shifting from the physical asset to a digital intelligence. So hiring a new type of professional to bridge the gap is what we are looking for. The summary of my presentation will be about the technology and the opportunity for young engineers. So we try to move away from the active where when we set plans, we see that the next will 10 of or will be 10 of the after it has around 4,000 or 8,000 or 10,000. So we do a sharp maintenance. But in this process, some things happen beyond our control, and a system trips, a compressor can go. So when this happens, you are going to lose $, which manager will get. So we need to have a technology that will tell us a system might strip or shut down in the next 2 days, 1 week, or 1 month before the system goes down. That's why we're going to talk about the technology called the digital twin. This is going to be the central to shifts we are trying to move from reactive to being proactive. And it also will help us to enable real-time simulations. So we'll do simulations on real time. You know, most of you, if you use high-size simulations for simulation, those ones are more of static way of doing simulation. And when you are running a live plant, you want to do a dynamic simulation, whereby whatever you are doing should reflect on what is on the field. It will also help us to do a proper predictive maintenance and also help us in plant operational optimization. The opportunity for young professionals is that you need to blend, you have to blend the engineering fundamentals to operational technology and information technology. So the future leaders will need to have this operation mindset of how do I connect a physical asset, that is the physical plant, with a digital intelligence. So as I talked about the reactive operations to the smart system, a scenario, I work in the, I'm at the natural gas compression station. What we do is that we take the gas that is coming from the gas processing plant at a lower pressure, then we increase it to a higher pressure. So we have a lot of equipment around, but our main equipment is the compressor. So the traditional way of dealing with a compressor is that we start it runs. Operators will come manually and check indicators. Are we in the right parameters? If we are not, we adjust it. That is a traditional way of doing things. Or we wait till something fails, then we'll fix it or replace it. And some of the elements are working in silos. You have the instrument system working alone, the nitrogen system working alone, the gen sets or power generation system working alone, and the compressor itself working alone. You want to move away from this kind of mentality and move to a very sustainable and very safe and efficient environment whereby you can intelligently be monitoring what is happening within the plant. Instead of just going manually and inspecting indicators, you want to know based on the data that is coming from the OT, that's operational technology. You use this data to help you in making decisions. And if you have a correct or accurate data, if you're able to clean it, it will help you in automation and optimization of your plant. So as smart energy extends beyond you using power or you consuming gas or you putting gas. It's all about you have to make it very intelligent. Having an intelligent integration of the entire value chain. That is the where the world is in now. And you must be for that. So I want to explain the term digital twin here. It's just a replica of your physical plant. So like my station, we are having compressor and a gas engine that is driving the compressor. That is a physical aspect, and that is doing the actual work.
Sorry to interrupt.
One
There is some echo at your background.
really.
Hello? Yes.
Am I the only one who can't hear anything?
I can't hear as well.
I think he's gone again.
It's not his
Please,
fault.
apologies.
Where he is,
Yeah,
the
he
network can be
probably
quite
logged
terrible.
out to work on the sound.
Yeah.
So we give him some time, maybe a minute or two, to see if he logs back in. If not, we would have to move to the next speaker.
Can you hear me?
Yes, we
Hello?
can. Yes,
Because
yes, it's okay now.
sorry, I don't know what happened. Yeah, I don't- So I was driving this between me. Listen, what?
Oh, we apologize for this. And can you show your reactions about how you feel right now? Please want to know, how is the session going so far for you? Can you react with the emojis here?
Hello?
Hello.
Yeah, can you hear me?
Yes, we can hear you.
And please, can you see my screen as well?
Yes, we can see it.
Okay. So as I described it, let me move it far. Try to summarize. What you're trying to do, you have a custom, you have a process land, but you have digital process land. So in this area, you're doing emulation, you're actually in the data is coming from your the transfers be a picture or data. So you're taking all time data and you need to create digital replica of the physical plan. That is what we refer to as a digital twin. It's a real-time digital replica of the physical art. So, but the difference here is that you continuously use data. You use it for monitoring performance and predict a certain outcome before the occur. So as a young professional, what you want to do is that, as I said earlier, since you are an engineering student or you are an engineering professional, you want to integrate the OT technology, the data that is coming from your plant, and you want to add the IT aspect of it, whereby the data is coming, you want to make sense of what the data is about. You want to find a better way of storing the data, be it in the cloud for safekeeping, because most of our data as an historian, that is the history of the data that is from the plant, and that is what you use to train meeting flow or to know what happened yesterday, what is about to happen. So you want to have a better backing up your data. And if you have a very huge data, you can develop your own AI model. So want to have the IT system to help protect data against maybe ransomware or data breach. When you have this intersected, that is where you have digital twin. So now we are able to in additional way of doing it, normally the OT, which is the operation guys, they try to work in silos. The engineering team work differently. Everybody works independently, and the IT guys, with the new world of energy system, the industry is trying to merge these three to solve real-time problems. So OT will give us the real data, operational from the field, and engineering, they design the system, and they know the knowledge about what the system is doing. So when we get data from the real data from plant, you infuse it into the engineering system. Then the engineer will now give you the context of what is coming from that, what is actually happening. Are you having overpressure in a vessel? Temperature of a bearing is reducing. The system will tell you that. So you now want to have an analytic system by maybe a dashboard instead of through thousands of trends. Try to understand what paint has ways. When you have a dashboard system, which is tell you the temperature of particular terrain, it's a click what is happening. As if you have effective dash system. So you don't want to in silo. We want to have engineers who understand the. If you understand it makes you ready for that energy that is. So to look at four scenarios, a digital twin can help solve. It will help to solve and plan downtime because running a plant, you don't know how the equipments are. You don't know the health of equipment because to them is very difficult to even handle or to know based on the old data. But we have a solid system, a machine learning system can know that thing of air is temperature in a certain and our game can tell the way temperature run. It's like to give up down. That is what you don't want. We want to have a maintenance, but we had the plan before doing it. So you want to fix it before it fails. If you also look at the safety aspect of Sometimes you want to do a certain operation because it's a live plant. After doing so many meetings, you want to go and test, and this is risky sometimes because it breaks certain things or it causes a lot of havoc or some hazard. If you have a digital twin system, which is a virtual replica of your live plant, you can test your scenario and know the outcome before going to do the actual work. The other thing is about the high costs. Usually, we have warehouses where we store our spare parts. Sometimes you don't even know that you don't have a particular spare part. Maybe a fan that is cooling an engine coolant. The belt suddenly broke down. We go to warehouse, they say they don't have the belt. In this case, you have to either get it from Accra or you have to fly to Europe. But if you have a condition-based monitoring system, whereby digitally you know the tension of the belt or the belt is wearing based on the pattern, you can procure your belt once before the belt goes back. The last I want to talk about is the slow decision. Because we don't normally make decision based in data. Most of the time, you end up wasting a lot of time before taking a decision. A typical example is we have a pipeline, we are flowing about 90 bar gauge of gas in it. One day somebody comes and say that the integrity of the pipeline, the pipe is deteriorating, so we have to reduce the pressure from either 90 bar to maybe 80 bar. The person just said it based on assumption. There is no data backing what he's saying. You get it? But when you have a digital twin technology that is monitoring the integrity of this pipeline, it is telling you what is happening within the pipeline anytime. And you can also sit to know what pressure is it able to be the pipe. So if you have a very well time visualization pipeline, taking decision will be better. So the technology here is going to organization move from doing this reactive proactive. I think I've spoken about this slide. So I'll talk about the new professional profile. Since we are moving engineers or young professionals have to know you are turning your gas system. Have to find way of designing the digital system or digital intelligence to help you move away from doing things reactive and be doing things faster and smarter. So the question is no longer that can you operate a compressor, can you operate a pump, or can you control a fractionation unit? No. Now the question is the fractionation unit is standing. What is happening inside? Can you translate or can you connect the physical aspect of it to the digital intelligence so that you'll be faster in taking decision or in optimizing your system? So your value as a professional is now defined by your ability to navigate between the certain innovation technology, operational knowledge, and engineering fundamental. Can't as one of the days. So let's have to put up what you have already as engineer you have fundamentals. You understand your dynamic, understand things very well. If you are in an industry, you also understand your operational knowledge, how the transmitters transmit the data and what the data transmitted mean. If you understand the logics, the SCADA system, the PLC systems, then you now move on to make sure you have the IT knowledge, as Engineer Mashud said earlier. You have to know how to do coding. It's not difficult, but you have to understand data analysis. Try and learn the Python, which is somehow easy for people to learn, but it's also difficult because you are doing programming. So if you're able to understand Python and maybe SQL too, and do more rotation, even you can also pivot to machine learning. So data that the OT giving you through machine learning can create a system for your industry. That is modern hybrid near. You don't want to be a petrol engineer. You'll be an engineer modest. Ranking today is finds data. Data is go to and have to know manipulate it. I have great insights. Data tells me. So it's somebody who understands data know how to manipulate data to make it a standardable set. Your mindset of the future leader is supposed to be, you have to be adaptive. The world is changing very rapidly. So you have to try and move along with what is happening. But there are so many information out there. Sometimes you need to lean on people who are experienced to show you the way. You have to have a system thinking mindset. Anything that you are doing in your work today, you have to ask yourself, what system can I build to help me move faster? And also be curious. Curiosity will help you bring out more things in you. So the most valuable professional are those who will remain adaptable and cultivate the holistic view of the energy ecosystem, because the energy ecosystem is no longer static. It is changing. Earth is changing. You also have to change. You don't have to be standstill. So last slide is I want to talk about that. I hope you are to breathe up because the future energy you want to do and trans. As I said, yeah, the physical assets of a machine digital. You understand we are shift from reactive smart. To recognize that you need to accept OT, and engine. So real engineering problem to embrace the digital twin technology to help you do things faster. And you also have to develop a hybrid skill so that you wouldn't be you wouldn't want to be an ordinary engineer. You want to be an engineer who solve problems. That is what we want from you. Thank you very much.
Thank you very much, Engineer Zakaria, for this insightful presentation. I think one thing that's run through the two presentations so far was that you kept mentioning coding, that we really need coding in this field. And thank you very much for this knowledge. We are very grateful. So next we'll move on to our questions and answers. Kindly type in your concerns, contributions, or your questions in the chat box, and they will be read out. And also, you can click on the raise hand icon and you'll be called to speak. Okay. So we have some questions here for you. Engineer Mashu, please, this is to you. Can you share your personal journey into the oil and gas industry, especially early steps you took when you had little or no experience? What strategies helped you secure your first relevant role? Yes.
All right, thank you for the question. And fundamentally, in this industry, apart from expertise, I always even tell people that expertise and hard work is placed second to network. Networking is very critical. When I completed bachelor's in petroleum engineering from UMatt and went to Tullow Oil for my national service, there were so many great guys from Tech and Shercy University and all of that. In terms of hard work, expertise, we're all competent, okay? But then a manager or a white man, I don't know, a manager generally would want to work with somebody he's comfortable with or she's comfortable with, okay? All right? You can all be competent, you can all have the qualities they need, but then what makes you stand out is the networking, interpersonal relationship. Okay. So learn to interact with people. When you meet someone, ask the person, how are you doing? How's your family? What do you do? I'm interested in getting to know you. You get what I mean? And so, even at the workplace, try as much as possible. When you go for your national service, talk to people, okay? Interact with them. Tell them how much you're interested in the work they do, okay? And if you put in the necessary hard work, I believe at the end of the day, you'd be able to navigate through. I moved to Tallow. From Tallow Oil, I moved to the National Petroleum Authority, NPA. Then at some point, I probably would have moved to Petroleum Commission, but I was chasing money at some point in my career. So I jumped from Petroleum Commission to Ghana Gas. That was just by the way. But I mean, primarily, what is most important and critical is networking, building good and strong interpersonal relationship with people. Thank you.
Thank you very much. Yes, what is most important is networking, and that we should learn to interact with people. Thank you for this contribution. And so, please, we have someone. Okay, someone, please, you can speak. Hello. Someone, please ask your question.
All right, thank you, Nancy. My question is to Engineer Masood. And then he spoke about the fact that transition is not a matter of an if, but then when or how soon. And I want to ask if, looking at how economically driven the world is by oil and gas, you're having Saudi Aramco, Chevron, Shell, PetroChina, all being big players in world economics. What do you say about how it's not very economically plausible to wipe out oil as fast as people are trying to? And then would renewables bring in as much money as oil is already given to the world and fill in that economic balance? Then the second question is about the geopolitics. If we would have world leaders, new world leaders come in all the time, whole idea of transition, are we really going to transition if we do not have, is it really sustainable in that sense? And let me just add a third one. Everyone is almost, we are telling students, young professionals to move into digital space and all that. Would that not, for some reason, make us move out of the traditional engineering space? I mean, we still need welders, we still need hands-on engineering skills, right? But for some reason, it's not preached to young professionals as much as the digital skills. How are we going to blend in? Are we moving all the way out or not? Thank you very much.
All right, thank you very much, my good friend and colleague. The first question you ask, if I got any of your questions wrong, kindly draw my attention, was how possible it is, how plausible it is for us to do the transition. And if you look at some very prominent economies that are mainly oil and gas driven, such as the Saudi Arabia, the Qatars, the Kuwait, the Venezuela, and all these, even Nigeria, right? That's why I said there's a lot of politics in this transition, right? Some people are of the view that, I mean, like President Trump of the United States, he thinks it's a hoax, it's a con job. So, but then okay, scientific research has proven that indeed the world as we speak today needs serious decarbonization. But then the whole politics and the whole dilemma has to do with the fact that some economies are primarily driven by these fossil fuels, right? Like Saudi Aramco, which is a very close ally to the United States of America. But we as engineers, okay, We are not politicians. I mean, there's a whole lot of geopolitics in this. Our objective and our role is to tell them the story. Now, look, hey, indeed, there's been so much carbon emission. Indeed, there's global warming. When you do life cycle assessment into details, right? There are so many what do you call it? Factors, so many detrimental factors you look at. I mean, you look at global warming, you can look at water acidity, and a whole lot of things that can really, really potentially affect everything we do in our environment, not just the global warming, even soil depletion and everything, soil leaching, etc., etc. And so it's a whole politics on its own that I may not be able to give you the right answer. But fundamentally, as engineers, we should be able to tell them the story based on facts and research. Sorry. And the second question, can you repeat that again, please?
All right. So I was asking about the way we preach the digital space, and then it's almost as if we are moving totally out of traditional engineering.
Okay,
I mean, we still need welders, we still need hands-on engineering works.
Yeah.
But it's almost as if it's go digital, and then we are sounding like we are leaving out traditional engineering, or we are making the importance of traditional engineering look less to young professionals and students.
I think the whole digital space is actually an arena to like my big brother Sule said, for engineers to be more efficient, for engineers to be more effective, and for engineers to work in a much safer environment. So I personally do not think that the digital space or the digital technology thing is there to sort of underpin or undermine the rules of engineering. You mentioned welding technicians and all of that. Do you know there are other people who are of the view that in the next coming years, AI might take a lot of jobs in America and other parts of the world? You'll probably have an AI doctor. You go to the hospital, those who sit in those rooms, I mean, consultants, not surgery. I mean, you go there, talk to them, oh, they're able to prescribe something for you, then you walk away, right? But then we are not there yet. So I think I understand your question and I agree totally with you. But the world is moving and it's not waiting for anybody. We are in a fast paced world, right? And people are getting other skills that separates them or that sieves them from the rest. And so if you want to be distinguished, you ought to move along with the world, right? You need to do things that are pertinent to securing a better future as the world is moving. Things that are more relevant, okay? So you're not moving away from your petroleum engineering or your mechanical engineering. Sule is very grounded in mechanical engineering, but he has digital skills too. He's talked about machine learning, and that's helping him execute his mechanical engineering rules or a compressor engineer more effectively and efficiently. Okay, so that is not to say that the digital space is there to take away the core engineering roles we've been used to, but then it is there to help us improve, and it is there to help us be more efficient and more effective. That's just what I have to say. Thank you. I don't know if I answered your question.
Okay, thank you very much.
Yes. The questions are answered. Thank you very much for contributing.
Okay, so we'll move on to our next question. And please, this is to you, Engineer Zakaria. So your current role involves multidisciplinary coordination. What are the most valuable technical and soft skills you found essential in your day-to-day work? And how would you recommend students begin developing them now?
Okay. So my day-to-day work is, as Mashud said, I work in a compression system. So you always want to make sure the compressor is working effectively. So as a mechanical engineer, you understand how the compressor is working. But what we try to talk about the using the digital system, when you're in the industry, there are so many things, especially when you are working in a plant, there are so many things happening at the same time. And humanly, you cannot know everything. So you need to consolidate things in a smart way. Because when the plant goes down, your CEO is going to receive a call from the minister. And if the CEO receives call from the minister, you will not be happy. You understand? So if you listen to my presentation, although I was moving fast, I was talking about three things. You still have to understand the engineering fundamental, because even if the data is coming, let's say a temperature is 90 degrees Celsius, what does it mean? Without the engineering fundamental, you cannot translate. So you still need your engineering factor. So back to your question, if you want to learn about what we do, you always have to go back to the fundamentals. If you are a petroleum engineer, you have to understand the fundamental, the principles. If you come to the field, you realize that what you were taught in class, you now see it, but you see it in a practical way. So make sure that your fundamentals are very solid. When you get it right, then you try and leverage the power of the IT to make you very different. That's what I can say.
Okay, thank you very much. So in the chat box, we also have some questions here. Where can, say, a service personnel start his or her job hunt, given the current situation in Ghana? Engineer Mashood, can you please take this?
Please, can you repeat the question again?
Where can, say, a service personnel start his or her job hunt, given the current situation in Ghana?
One of the most difficult questions I probably would answer today. I'll just start by saying that it's rather unfortunate that due to some situations, political situations, it's been a difficult thing trying to get a job or start from somewhere in Ghana. Private companies previously were the hope for young engineering professionals to start their career from. But in recent times, things have been quite tough. As we speak, we know oil prices, global crude oil prices are down. And so if the question were what programs to read or to pursue to be able to position yourself properly for jobs, I would have probably recommended. But then again, if you're not just, what do you call it, coming from the oil and gas industry, I mean, from the oil and gas background, let's say petroleum engineering specifically, which is very specific to the petroleum industry, and you have a mechanical, electrical engineering background, etc., try and consider the mines, okay? Because I'll be very honest with you, you would have a great deal of stuff to learn when you go to the mines. It might be difficult to get in, but keep applying. When it comes to unemployment and all of that, it's everywhere in the world. In Canada, it's there. In the UK, it's there. In America, it's there. The opportunities, they keep coming and going. And so when you're lucky, then you get picked. And these topics we're discussing today are very important. That's why we're telling you, we're encouraging you to equip yourselves properly so that when the opportunities come, you don't miss it. Because when you come out as a petroleum engineer or a chemical engineer from KNUST, and there are so many of your classmates who probably even did better than you in terms of what class they came out with, or even if you have the same class, there are other students in other schools, from UMass, from the other universities, right, who have the same degree. How would you stand out? And so I would encourage you not to give up. Just keep applying to the private firms, because as for the government firms, you won't be called. I'm going to be very blunt with you. Those are highly political, and I shouldn't be saying it on this platform, but I'll tell you that's the truth. And so it's unfortunate that as a country, we are not looking at what do you call it? We're not recruiting based on merit or whatever, but then it's also as a result of the numerous heap of graduates we have. That's how it's supposed to be, or that's how it's become. And so look at the private firms, keep applying and remain determined, do not give up, and hopefully your day would come. Yeah.
Okay, thank you very much. But Engineer Marshall, could you please recommend the courses you mentioned? You said you recommend some courses, and in your presentation, you also mentioned one, which is the LC, the Life Cycle Assessment Certification. But aside that, are there any other courses you can recommend as well?
Okay, so just have a fundamental coding knowledge. Start with Python. Okay. I'll use myself as an example. I'm doing my PhD in chemical engineering, and I never knew that coming to do my PhD will require me to know these stuff, because what I'm doing now is primarily machine learning. Okay. We are moving from the whole Aspen HYSYS thing to monitoring to be able to do better predictions for plants. Okay. And so just these are soft skills. You can go to YouTube, you can learn them, or Udemy. You can buy a course for as cheap as $14. That's about $140 or 150. I mean, 140 cedis now, or 150 cedis because dollar is down, I guess. And so these courses are on Udemy. Udemy is a very good academic platform. I encourage you to look at courses over there. You can use about a week or 5 days or even less to learn a course, and you'll be given a certification on that. Okay. And so anything that has to do with coding, it could be Python, it could be SQL, like Sule mentioned, for data analytics, etc., etc. Okay. So get those skills on top of your engineering degree, and I believe you are well equipped. Thank you.
You're welcome. All right, thank you. Please, Richmond, you can go ahead with your question.
Okay,
Hello,
thank you for the
Richmond.
opportunity. Hello. Please, thank you for
Yes,
the
we can hear
opportunity.
you.
Yeah, I'm from UMass, and my question is, as the world is changing from the manual and digital to the machine learning AI, I want to know which aspect of our industry, that as petroleum engineers and petrochemical engineers, which in the energy industry as a whole, which aspect should we focus so as to not lose our jobs to artificial intelligence and the machine learning stuff? Although we are equipping ourselves with the modern trends like the Aspen HYSYS, the digital system too. So which aspect, like, I want to know which aspect of the industry that you will not lose your job if, like, things get critical, like, to stay relevant in the energy sector.
Okay, thank you. Engineer Zakaria, please, can you help us with this?
Okay. That's a very nice question. And we've already mentioned what you need to do several times. So you just have to, as an engineer, the AI is coming whether you like it or not. You just have to be ready for it by utilizing the IT space. So Majid talked about you trying to learn Python, which normally even the AI is what we use, the language they use for AI is majority is Python. So if you are a petroleum engineer who wants to be ready, or you don't want AI to take your job, you have to know how to leverage this technology. Let me give you a typical example. In our plants, we generate, if not 100,000 of data a day. At the end of the month, your manager will expect you to write a report of what happened within the month, sometimes weekly, bi-weekly, and a month. So if you know Python, example, you can know how to automate or how to go through the thousands of data collected, visualize it, and make it very presentable to your manager. That is if you are working. And if you are not working, you are now looking for a work. If you tell a manager or you tell an interviewer that I can automate your system, instead of you doing things the manual ways, I can help your team to be more effective by using a language called Python or by using a language called SQL, which will help you. Most of your data will be fragmented, but I have a skill in a language called SQL. That is structured query language. So with that skill, I can help your company structure your data very well. So any day a manager is looking for a data or information, we can fetch it with just a click instead of going through thousands of data. So these are the skills you need to have to be AI resistant. I hope you understand what I'm saying.
Yes, I've understood. And my second question is, you see, hello,
Yeah, talk.
please. My second question is, you see, as an upcoming engineer, we are being equipped in our school that with this and we are pursuing. A lot of people have been there for 20, 30 years. How do we leverage our expertise so that we collate with them on they not being familiar with this new technology and new AI things? Because some of them don't have any idea about this AI machine learning stuff. They only know the old stuff that they are doing. And when you go and try to even let them know, they will tell you that, oh, you are just a young boy that you are just in the game. Just keep quiet and learn what you are doing. So how can you leverage your expertise so that you cooperate with them and get to know how like we can do that? Maybe you teach they will teach us the manual stuff and we to educate them on the new trends so that you all work together to achieve the target that you want.
Okay. If you are an engineer, you are not only about the technical aspect of engineering. Since you are going to work with people, you need a communication skill. So you also need emotional intelligence. So whoever you are going to talk to, if you know the person doesn't understand what you are talking about, you have to find a way to let them know. You don't go and be imposing what you know onto them, because they have been doing things the old way and they like it that way. Probably they will not even appreciate it. So you have to show in the work. You get it. If maybe they've been using Excel to be populating the list of parts of an equipment, you can come in and say the using Excel is the old way, but not by showing that a machine learning can do a better prediction. Or even if the person is into machine learning, because as we're talking about Python, people also use a language called R for data analytics. You get, so the person might be into R and you want to teach the person about Python. So you first have to understand very well and apply your communication skill and other soft skills to let them know. It's not about engineer. You always have to be too technical. Sometimes you have to be very friendly and let them know what you want.
All right, thank you very much. So we have our final question here, and Engineer Abdallah, please, this is to you. For students who feel underqualified or lack direct industry experience, which entry paths, for example, internships, contractor roles, graduate programs, or technical certifications, have you seen provide the best stepping stones into meaningful careers?
Okay. I always advise that at least the national service or internship you do during your 4 year bachelor's degree or after your 4 year bachelor's degree. It's some form of experience, okay? And so if you have the opportunity to do graduate programs after your national service, is highly recommendable. It's it's one of the best ways to go. Um, we're talking about other soft skills that would equip you to look or to appear marketable to employers. But then again, employers sometimes do require some experience, some level of experience. Okay. And so Ghana is already giving you 1 year of national service. Just that if you're not lucky, you might not get to do that 1 year in your relevant field. But then if you are lucky to do so, and after that, there's any graduate program, which I think the mines actually do a lot. They offer opportunities for young graduates to do a 1 year graduate something program. It's a very good thing. Certifications are very important, but then again, having the very baseline experience is also a very good thing as a young graduate. And so I'll recommend graduate programs. And if you have the opportunity, you can still go ahead and do some of these certifications as well. I mean, whilst you're so we're looking at experience cum certifications, right? And so but the graduate program is something I would always prioritize first before the certifications. So you can, whilst you're doing it, and I mean, you have the opportunity to pursue these few certifications and do it one at a time. Don't just rush into it. You can start with it as a hobby, just YouTubing and trying to see what works best for you and all of that. Once it becomes a hobby and you're passionate about it, you'll be able to build upon it whilst pursuing your graduate program. And so, yeah, thank you.
Nancy,
All right,
let
thank
me
you.
add this.
Sorry.
Let me add this. Sometimes you can apply to institution not for employment. You apply for internship. Some institution also allow, especially the mines and other places. So instead of applying for you are looking for employment, you apply for internship so that you can have the experience Engineer Mashudi is talking about. Thank you.
All right, thank you very much. So you can apply for internships and we'll get through with what we want to do. All right, we are very grateful for your submissions, Engineer Abdallah and Engineer Zakaria. So we'll move on to our next item. We have some few announcements to make. Kindly visit the SP websites and sign in if you are new here and create an account. And also go to the membership section and select join or renew membership. Yes. Please choose professional membership and new professionals may complete the application form as well. We have existing members who may want to review or update their information as well. And kindly pay the registration or renewal fee, and that's as a cost of $4.5 for new members and 2.5 for the renewing. Please, you will receive a confirmation email after this and your application will be complete. Kindly log in to access your SP member benefits as well. All right, so we have these upcoming events, which is the Mentor a Student Today and the SP Ghana By Now 2026. Kindly stay alert for all these as we'll be having them soon. All right, thank you very much. Please, we'll have Samuel Mawuklem to give us the vote of thanks. Samuel.
Yes. Thank you
Hello,
for that.
Samuel. Okay.
So would thank Engineer Suleiman Zakaria and Engineer Abdallah Gali Masood for sharing their experience, knowledge, and ideas about transition with us. It's refreshing that we engineers who have gone ahead of young professionals are telling us the truth about what is going on out there, and then making us ready, both students and young professionals, to be ready for what is coming and telling us how to prepare for the storm that is coming. We know they are busy. Engineer Mashoud is in the United States. The time may not be favorable for him, but he took time out and he's here with us. Engineer Suleiman is operations engineer at Ghana National Gas Company. Out of all his busy schedule, he's here to share with us. We are grateful. We have so many participants today, and then we cannot mention all the names, but we want to say we are grateful for everyone for joining in. The senior members of the SPE Ghana section who have joined us too, we are grateful. Members of the Career Guidance and Outreach Committee, thank you for being here with us. Thank you to our host, Nancy Osei, for leading us through a successful session. We are grateful, and then we'll see you in the next one. Thank you.
All right. Thank you all so much. Bye.